2, 2. So let me minimize this. So, quick question. For the recording, if you guys should know the hustle bustles because we were just talking about registration. Okay, but now let me bring it together. Write down these. Okay. Take a look at this graph. In your groups, I want you to take a minute and I want you to decide what area on the graph would represent profit. What area on the graph would represent loss? And what part of the graph would represent a break-even point, and what does it mean? So just remember that the green line, that's the money brought in. That's the money you get from selling your tickets. The red line, that's the money you spend. So green is the money you take in. Red is the money you've spent. All right, so take a minute in your groups. I give you 30 seconds. Okay. Grace?
Yeah.
Yes. Yeah, I'm getting the names down. It's hard when you're gone for, like, you're only in school for 4 days and then you're gone for a week. But, okay, so Grace, what did your group decide? Like, where on this graph would you consider profits to have?
Where the income line is above the expense line.
Where the income line is above the expense line. So this, ooh, come on. This section right there, those are profits. And technically, if I wanted the actual dollar amount of profits on any given day, I would do whatever I have here minus whatever I have here. Income minus expenses, and I'd end up with profits, right? So actually, technically, the length of this line would be my amount of my profit. Okay. All right, so there's our profits. Everyone agree with that? Income is higher than expenses. Where are the losses? Jose, where are the losses? Oh, are you trying to throw me off?
Yeah. The other triangle thing.
The other triangle thing, right here. Right? Expenses are higher than, so the money you spend is higher than the money you take in. Does it make sense when you're first starting out that your expenses might be bigger than your income? But then there comes a point called your break-even point where you actually spend what you make and now you start to make money, right? So most businesses starting out, the expenses are higher than the income. It just costs a lot to start a business. But then you hit a point, and then after that, hopefully you're profitable from there on. Not always, but on this graph. Okay, good. Today we're doing systems of equations, linear systems. So it says 2-1, but this lesson is actually 2-1 and 2-2. You get a 2 for 1 today. And that means you get a 2 for 1 on your homework, too. Right? Yeah. Yep, 2 sections today. Yeah. No, it's not that many problems. Yeah, it's normal. All right, we good? So it's 2-1 and 2-2, both linear systems. So the first 5 slides that we're going to do should all, most of the day really, should all be review. But I'm going to teach it to you as though you haven't learned it before, even though you have. And I'm hoping that as we walk through the problems, you'll go, oh yeah, I remember this, right? Right, Grace? Okay. All right. So when you're solving a system of linear equations, linear means lines, right? When you're solving a system of linear equations, it means you're looking for the point where the equations have in common. You're looking for where they cross. So the solution to a set of linear equations is an ordered pair. It's a point. It's a dot on the graph. All right. So we're going to start by solving with substitution. Now, when you solve by substitution, your first job is to solve for one variable in either equation. And here's a little hint.
pick one with a coefficient. Do y'all know what coefficient means?
Yeah, the number before the variable.
Yes, very good. With a coefficient, the number that's being multiplied in front of the variable. Pick one with a coefficient of 1, right? If there is one. Oops, I can write of 1. If there is one, pick it. Because if you pick a variable that has a coefficient of 1, you have less fraction work to deal with. So now I like fractions, so it doesn't bother me either way, but it is a little bit faster to go without fractions. So tell me X or Y, which letter would be easier to solve for? Y, in the first equation or the second equation?
First.
The first, because that's the variable with a coefficient of 1. Does that make sense? So I want you to all take a minute, take this equation, and solve it for Y. When I say solve for Y, do you all know that means get Y by itself?
Yeah.
Okay. Okay, now you've got fractions. If you solved it for X, you would have had to divide it by 5. I'm going to put on my glasses and come see what you're doing. Oh, you solved for Y. You just solved the whole problem. We're not done yet. We're just doing this first step. You're like 10 steps ahead of us. Okay. All right. So in order to solve, I'm going to rewrite it down here. So I have to add 5x to both sides. And I get y equals 5x minus 1. Are we all good there? Okay. Okay. All right. Now here's why it's called substitution. It's called substitution because you take whatever you got and you substitute this for y in the other equation. So in the other equation, you replace the y with 5x minus 1. So I'm going to write that down. You guys can go ahead and start working on that if you want, but I'm going to put step 2. Okay, substitute this in for the variable in the other equation. By the way, if I put 5x minus 1 equals 3x plus 12, what does the 5x minus 1 have to go in? Has to go in parentheses. Parentheses. Do not forget the parentheses. So every time you solve by substitution, you're going to be putting parentheses. Now you have one equation with one variable, and you can solve for x. Are you ready to walk me through this? What should I do first? The 2. Well, yeah, and so we're going to distribute the 2 in, so what do you get? 10x minus 2. Very nice. All right. Now there are several ways I can go next. What would you like me to do next?
Minus 3x.
Okay, minus a 3x. Tori agrees with you, so that's good. All right, so 7x minus 2 equals 12. Now what? Add 2. 7x equals 14. What's the last thing? Divide by 7. X equals 2. Hey, I'm done. That's my point. X equals 2.
No? You do it. What do I need to do? I need the y. All right. So because your answer has to be an ordered pair, it's a point where they cross, right? So how do I find y? I'm going to plug the 2 in right here. So my y equals 5 times 2 minus 1. So what's my y? 9. So my final answer, so I got x equals 2, I got y equals 9. But my final answer is 2, 9. And that's the actual answer. Okay? It's an ordered pair. Has to be in parentheses because it's an ordered pair. All right, how are we feeling about that? Ready to try one yourselves? This one's even easier than the last one. See if you can do this start to finish. Because I'm going to wear you out with the constant talking about the upper level math classes. But I just want you to know the higher you go, the less you get to use a calculator. So it would be good for you, not just to prepare you for future math classes, but also just to grow your brain, to try to do as many of these problems with mental math and fractions instead of going to your calculator every time. Force yourself to do some arithmetic with your own brain, right? Good for you. Every time you do, your brain grows a little bit.
But when I'm working in the real world, I get to use a calculator whenever I want.
Do ya? You can carry a calculator to the grocery store?
I could.
Makes you feel
Yeah,
smart.
that's true. You're right. But in your real world happens in the next 2 years where you won't get it. So gotta get used to it. Okay. So I'm replacing my y with 15 plus 8x, right? Do y'all? This goes in here. Does everyone understand the substitution part? Okay. All right, so I'm going to go ahead and distribute that negative 5. Okay. So now you have negative 10x minus 40x. They're on the same side, so you just combine them. You get negative 50x minus 75 equals negative 30. If I add 75 to both sides, I get negative 50x equals 45. Divide by negative 50, x equals negative 45 50ths, which reduces to negative 9 tenths.
Oh, I see why.
Okay. Be careful with those negatives, right? The negatives are an easy way to miss stuff. Yes, Joey?
So we're going to do the ordered pair in fraction.
I'm going to do it in fraction. I will allow decimals, yes, if your test allows calculators, which I don't know if it does. So, okay, let's go ahead and find y. Y equals 15 plus 8x. So y equals 15 plus 8 times negative 9 tenths. 15 minus 72 tenths. So 100, let's see, you know what, I'm going to reduce this first. 36 fifths. So now I have 75 fifths minus 36 fifths. So it would be 39 fifths. So my final answer is the ordered pair negative 9 tenths, 39. That's a 5. 5. There, 39 fifths. Everyone feel at least somewhat of an understanding of substitution. Anyone remember the other major algebraic way of solving? Elimination. All right. You think elimination is easier?
Yeah, I kind of like something.
You know, honestly, it just depends on the equations which one is easier. Yeah. Okay. Just so you know, when you get into systems that are non-linear, which I don't don't know if we ever do in this class or not. But when you get into nonlinear systems, it's almost always substitution that you have to do. But anyway, elimination. When you do elimination, you want to get this, you pick X or Y. Doesn't matter which letter you pick, but you need to have the same coefficients with opposite signs. That way when you add them together, that variable is eliminated. It becomes 0. So we're looking for step 1. So you need to multiply your equations by whatever gives you. So multiply 1 or both equations as necessary to get the same coefficient with opposite signs.
Is this 2.2?
No, so I think we're still in 2.1. Okay. Hey, what do I need to multiply these equations by? Nothing, because the y's already have opposite signs. So once you've got same coefficient, opposite signs, you just add straight down. So what's 4x plus 3x? 7x. Those are gone. They become 0. 14 plus 13? 27. Divide by 7, and x is this gorgeous fraction of 27 sevenths. It's beautiful. How do we find y? Hey, here's a question. Does it matter which equation I plug my x into? No. They have to both be the same, or it's not a point that's in common, right? They have to be the same. So you pick whichever equation you want to use to plug your x in. Should I use the top or the bottom? Bottom, because the numbers are smaller? Okay. 3 times 27 sevenths minus 3y equals 13. Now, if you want to multiply, so there, just so you know, there's a little trick. How many of you, be honest, how many of you do not like adding and subtracting fractions? Okay, well, there we go. Okay. So if you don't like adding and subtracting fractions and you have an equation with a bunch of fractions in it, you can multiply, remember it's an equation, you can multiply both sides by whatever you want, right? If you multiply both sides by the LCD, the denominator, you'll get rid of your fractions. So you got to multiply every term times 7. 70 plus 21, 91. And now you can work with it without the fractions, right? I know. You're still going to have a fraction at the end. But you don't have to worry about doing 13 minus 81 sevenths. Yes?
How do you do 13 times 7 in your head that fast?
I just do 7 times 10 plus 7 times 3.
Oh, that makes sense.
Right? 70 plus 21. Did you guys, like when you did mental math, right? Did you ever break it down into... Yeah.
It's just a bunch of short numbers.
Yeah. Okay, so subtract the 81. And y is this gorgeous fraction of negative 10 21st. I love it. Okay, so our final answer is the ordered pair in parentheses, 27 sevenths, negative 10 21st.
I love this.
You love this?
I love it.
I do too. That's great that you love it, Joey. Yes, Jose. Good question. 5, please. When you have a fraction, is 10 over negative 21 the same as negative 10 over 21? Yes. Makes no difference if the negative's on the bottom or the top. Or could I put it like this? Could I put it like out front like that? Same thing. Same. Yeah, makes no difference. Where does a negative go?
Like this stuff? Absolutely. Yeah. All right, so here's one for you guys to try on your own. This one you're going to have to do some. All right, so most groups, from what I observed, chose to eliminate the y's, which means we'd have to multiply the bottom equation by -5 so that we could get a +5 and a -5 in front of the y's. So when we add them together, we get -13x equals -24. Hey, what's a negative divided by a negative? It's a positive. So x is 24/13, which is a beautiful number. Okay. Y, 2 times 24/13 plus y equals 6. So we get 48/13 plus y equals 6. I'm going to go ahead and just subtract it from both sides. You don't have to. You can multiply everything by 13 and then divide, whatever you prefer. So y equals 6 minus 48/13. Let's do 6 times 13 fast, right? It's 60 plus 18. So you get 78. So our final answer, 24/13, 30/13. How did we do? Luke, how'd you do? You got it? Are you guys using fractions or decimals?
I like decimals.
Do you know what I don't like about the decimals for these is you have to round them, which means they're not exact. The more you practice with fractions, the easier they get. Any questions on just the elimination part, regardless of fractions? Jesse, how you doing?
I did it differently.
Okay. Did you get the same answer?
For x I did, but then for y, I got y equals 1 and 1/5.
1 1/5? Okay. So it should be 2 4/13 if you're doing it with, okay.
Yeah, because
So-
I got to the step where I plugged it in, and then it's like 72/13 and plus 5y equals 6.
Wait, how'd you get 72/13 plus, oh, you plugged it in up here. Okay, so it's -72/13 plus 5y equals 6.
After that, didn't you say you can multiply both sides by the denominator?
You can. Here, let's go ahead and do it that way. So you have -3x plus 5y equals 6. Let me write this down. -3x plus 5y equals 6. Write down, please. So you have -3 times 24/13. All right, Jesse, are we on the same page so far? Okay. So -72/13 plus 5y equals 6. So you decided from here to multiply everything by 13, right? So you get -72 plus 50 plus 15, 65y. 60 plus 18 equals 78.
Yeah, it was actually Beth messed me up because she told me it was both sides.
We're blaming
but-
Beth.
No, because she said only multiply the denominator and the other side, of that, not all of them.
This is an equation.
Yeah.
This isn't
Now
any.
I see it.
Algebra never changes. So it's not like just because there's a fraction in an equation we get to do a trick. This isn't a trick. It's multiplying both sides by the same number. So whenever you have an equation, you have to do it to the whole side, right? Both whole sides. Okay. All right. All right. Throwing Beth right under that bus. All right. There's some terminology you need to know. You don't have to write down all of this, but you should write these 3 pictures. And I'm going to label these pictures with some vocab. When you have 2 lines and they intersect at a single point, which is what you see most often, every one that we've done so far was like this. If you get an answer and it's an ordered pair, this is what your equations looked like. They looked like 2 lines that crossed. When you have 2 lines that crisscross, the system is called consistent and independent. Consistent and independent. So if you have two lines that cross at one spot, the system is called consistent because there's a solution, and independent because there's only one solution. If you have two lines that are right on top of each other, so basically they're the same line, right? If you have two equations that are exactly the same, every single point is a solution because every single point is a point they have in common, right? These are called consistent and dependent because they have a solution, but it's like every solution. If you have two lines that are parallel, that never ever intersect, then the system is called inconsistent. So you have some vocab to learn. Regular single point solution, consistent and independent. If every point is a solution, consistent and dependent. And if there are no solutions, then the system is inconsistent. Does everyone have the three situations? Do you need another minute? It's okay if you do. That's fine. Okay, so if every single point on the line is a solution, then the system is consistent and dependent. Basically, if they're the same line. Bless you.
And what about the other one?
There's just one solution. They just cross at one point. All right. Let's see if you can put your knowledge of lines to the test. Okay, real good. Okay. All right, I have two systems up. For each system, I want you to label it either as consistent and independent, consistent and dependent, or inconsistent. You can do this with almost like no solving at all. Like very little writing is required to answer this question. You should be able to just look at both of them and make a decision. I'm going to give you a minute in your groups to discuss. The first one. Yeah. Consistent and independent is correct. What made you come to that conclusion? Consistent and independent. And it's fantastic that you said I just looked at the slope, because as soon as you have different slopes, whenever your slopes are different, there is no way those lines are going to be parallel, and there's no way they're going to be the same line, which means as soon as you have different slopes, you know those lines are going to crisscross. You don't have to look at anything else. This one's kind of a trick, because when you first look at it, you think, oh, hey, the slopes are different. But are the slopes different? No. Right. Ishani says divide the second equation of 3 by 2. They're the same line. The exact same line, which means this solution is consistent and dependent. Consistent and dependent. How do we know? Because not only do they have the same slope, whoops, I can write same slope. Same slope normally would mean parallel, right? But they have the same slope and same intercept. Then you're going to end up with the exact same line right on top of itself. Any questions? Good. We're going to do one more, and then I'm going to skip the last one, all right? One more. So just so you understand where you're going with this. So one word problem. Min and Daniel are starting a business. They need to decide between cell phone plans. One company offers the Connected Colleagues plan. It's $40 a month for the first phone, plus $35 for each additional phone on the plan. A competing company offers the Small Business plan, $60 a month for the first phone, and $25 for each additional phone on the plan. Which plan should they choose? So without doing any work, do you have an idea of which one would be the better plan? Why the first one? Adi, that was you? Yeah.
Yeah. We could just have just doing a little bit of math. 40 plus 35 is 75. 60 plus 25 is 85.
Okay. Yeah, and you know, it took me reading this, I read it through twice. My interpretation first was $40 a month plus another $35 a month for the second phone. But then thinking about what unit we're in, I think that the author wanted you to do it as $40 a month plus a flat $35. So it was just $40 a month plus just a flat $35. And then this was $60 a month plus a flat $25. So either way, though, you still want the first plan, right? Yeah. Even though this one you have to add an extra $10, it's $10 higher for the extra phone. It's so much less per month. You're going to pay way less, right? So my first question to you, if we were to write equations for these, for this first plan, $40 a month plus 35, how would you write that as an equation, as a linear equation?
Equals 40x plus 35.
40x plus 35, what does the x represent? Number of months. Very good. 40x plus 35, where x is in months and y is in dollars that you have to spend. All right, so this right here, this would be for the Connected Colleagues plan. And then the Small Business plan, what would that equation be? 60x plus 25. So you have two different plans. So which plan should they choose with doing very, very little like thinking? You know that this is going to be the better plan. This is going to have the lower price. Not the first day, but really quickly, right? This is going to have the lower price. I personally would know which plan to choose by graphing. I think I'm a very visual person, right? So my brain immediately goes to graphing. If you do substitution and elimination, that'll give you the break-even point. That's where they're the same. But then you'd still have to decide which one's, higher after and which one's lower after that break-even point. That's why I think graphing is the best way for this one. If all we're doing is determining a plan. So like 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Going by tens and so forth. 1, 2, 3, 4, 5, 6, 7, 8. First plan, we start at 35. We go up 40, 10, 20, 30, 40 over 1. We have that for our line. Second plan, we start at 25. So we start a little lower, but we go up 60. Go over 1. And we get that for our line. Which means it's before even the first month that the second plan is already more expensive. Yes.
On the test,
Oh, I'm sorry. Okay, Isaac, yes.
on the test, would we be able to just use graphing? And will there be like graph paper there, or will we have to use substitution?
You will definitely have graphing, which we will give you graph paper. There will also be substitution, and then you'll have to do it that way. We're going to make you do everything. Yeah, the test is going to be a really nice variety. Yeah, so, yeah. Tell me what make the X 12. Oh, you mean for the first year? So like plug in a 12 and see which one's bigger. Is that what you're saying? Yeah, that's a way to do it. So once you find your break-even point, if you want to know which one's bigger, you can plug any X value beyond that number in and see which plan is bigger. Yeah, so X equals 12 is fine, and you'll know right then. Anyway, okay. So if we want to actually solve, we could solve like to find the actual value. Just so you know, it's at a half month that they end up being the exact same, and the price is $55 at the half month. But to just get a visual of which plan is better, sometimes graphing is your best bet, right? Now, homework.